Okay, for lecture 35, part 3, we are going to talk about factorials. I know that you guys have heard about these before. We're going to do a quick review, and then we're also going to talk about what to do if variables are present. So, first off, what is a factorial? In factorial, okay, that in explanation point is said in factorial. What that means is, if I have in factorial, I'm going to take whatever n was times n minus 1 times n minus 2, and that pattern is going to continue on down until I get to 1. Okay? So if I say that my n is 7, I'm going to take this times 7 minus 1, which would be 6, times 7 minus 2, which would be 5, times 7 minus 3, which would be 4, times 3 times 2 times 1. So we're essentially just stepping down by 1. So if someone were to ask you what 3 factorial is, then that would be 3 times 2 times 1. And we would multiply that out to see. 3 times 2 times 1 gives me 6. If I were to find 6 factorial, that would be 6 times 5 times 4 times 3 times 2 times 1. Okay, if I multiplied all that out, that would end up being 720. Last one, if I have 10 factorial, that's 10 times 9 times 8 times ... 3 times 2 times 1. There are buttons on your calculators. If you have the standard ones that I usually have in my classroom, if you click the PRB button, you will be able to scroll to find your explanation point, and you can just plug in a 10 factorial. If you do that, you will get 3,628,800 for our answer there. Okay, there is one special case, 0 factorial. 0 factorial equals 1. I'm not going to spend a lot of time discussing that with you guys, why that is, but there is a YouTube video by Numberphile, and I will link that up if you are curious, why does 0 factorial equal 1? Okay, moving on. We are going to be asked to cancel factorials. Now, I've got a 6 factorial over 3 factorial. If we look at that, you could plug that in your calculator, and that's not going to be an issue at all. Okay, you can plug in 6 factorial, plug in 3 factorial. Now, if you move to this next one and tried to plug in 90 factorial and 87 factorial, your calculator is going to come up with an overflow error. Okay, so we want to come up, it's a fairly easy way to simplify with our factorial. So if I have 6 factorial, that's technically 6 times 5 times 4 times 3 times 2 times 1. Okay, if I have 3 factorial, that's 3 times 2 times 1. So if I look at this, I see that there are some factors that I could cancel, right? They both have a factor of 3, 2, and 1. So this section right here, I could cancel those. However, if I also look at this, 3 times 2 times 1, we have learned that we can rewrite that using a factorial. Okay, so actually, I could rewrite this as 6 times 5 times 4 times, we know 3 times 2 times 1 is 3 factorial. And on the bottom, I've got 3 factorial as well. So when we're dealing with these, if I have a 6 factorial, I can essentially stop that at any point I want to and finish it with a factorial, and that will give me my answer. So since I've got 6 times 5 times 4 times 3 factorial, I can cancel these, and I am left with 30 times 4, which is 120. That's my answer. Like I said, it seems a little monotonous for that one since that's simple enough, but it will make a lot of sense for these down below. Okay, so if I have 90 factorial, I can essentially write these out. 89 times 88. And I'm going to write this out, but I can cap it at any point. I could stop it right here and put a factorial. And that's still the same thing as 90 factorial. I don't want to cap it there, though. I would want to cap it at 87 factorial. Why? Because the bottom has an 87 factorial. Okay? So I can cancel those there. I'm left with 90 times 89 times 88. And if I do that, that gives me 704,880. Okay? So again, that will help you alleviate your calculator from getting that overflow error. Next one, I've got 100 factorial. Okay, again, I can cap this anywhere I want to. Where do I want to cap this at? Well, if I look at the bottom, it's got a 98 factorial. I should probably cap it there. Okay, do you really want to write that all the way out to 2 and then cap it at the 2 factorial? No. Okay, so even though, this is important, if I have a 98 factorial and a 2 factorial, I cannot multiply these two together. They're left separate. Okay, it's got to be a 98 factorial times a 2 factorial. But when I do this, I can still cancel that 98 factorial there. So I'm left with 100 times 99, which gives me 9,900, over 2 times 1, which is just 2. So I get an answer of 49,050. Okay, that canceling is going to be very helpful in your statistics type classes. Okay, now we're getting to the more difficult problems. Canceling factorials with variables. Okay, first thing that you guys need to remember is if I have n factorial, okay, if we remember from the beginning, that was n times n minus 1 times n minus 2 times n minus 3, and so on. It kept going on until we got to 1. Okay, so we're going to need to use this knowledge here to help us cancel these. Because what we're going to do is we're going to have to either write out this one or write out this one until we reach a point that we can cancel. Now, how do I figure out which one I need to expand, like what we were doing on the last time? Well, you need to ask yourself, what's bigger? Whoops. Is n bigger than n minus 1? Which one's bigger? Is n greater than n minus 1, n less than? Well, n would have to be bigger than n minus 1. I could check that. Plug in a 2 for my n's. What's bigger? Well, 2 would be greater than 1. 2 minus 1 gives me 1. Okay? So I want to expand whichever one is bigger. So since I know the n is bigger, I'm going to rewrite that as an n times n minus 1 times n minus 2 times n minus 3. And I can cap this as any point, right? Did I show too much work? Yes. I would want to cap this right here at my n minus 1. How do I know that? Well, because there's an n minus 1 factorial on the bottom. So just like I can do with my others, whoops, I could cancel my n minus 1 factorials, and the only thing that I'm left with is just an n. And that's my answer. If I look at my bottom example down here, I've got an n plus 1 factorial over an n factorial. What's bigger, n plus 1 or n? Well, n plus 1 would be greater than just a regular n, right? This is 1 more than n. So I'm going to need to expand my n plus 1. Now, we haven't done that before. Okay, if I have an n plus 1, what's one step down from n plus 1? That would just be an n. Okay? Think about it. If I have, say my n was 3, so I had 3 plus 1, what would be 1 down from 3 plus 1? Well, 3 plus 1 would be 4, so 1 down from that would be 3. Okay? So I've got an n plus 1 times n. Am I ready to cap it there? Yes. Because on the bottom, I have an n factorial. So I could cancel my n factorials, and I'm left with just an n plus 1. Okay, next example here. This is a little bit more complex. Okay, I've got 2 factorials on top. And on the bottom, I've got an n minus 1 factorial squared. When something's squared, that means that it is times itself, correct? So really, what I have here is I have an n factorial on top, and I have an n plus 1 factorial next to that. And those are both over. I've got an n minus 1 factorial, and I've got another n minus 1 factorial. Now, I wrote those in 2 different colors so that you guys could see. I'm going to need to cancel these 2 together, and I'm going to need to cancel these 2 together. So I'm going to ask myself, what's bigger, n or n minus 1? Well, my n would be bigger than n minus 1. So I'm going to expand that. N times, next step down is n minus 1. I want to cap that. because that's what I'm looking to cancel. On the bottom, I already had an n minus 1 factorial. Now up top, I've got an n plus 1 and I've got an n minus 1. N plus 1 would be bigger than n minus 1. So I'm going to expand that. N plus 1 times, the next thing after n plus 1, remember, is n, times n minus 1 factorial. And then on the bottom, I already have an n minus 1 factorial. So now that I've expanded those, I could cancel these n minus 1 factorials together, and I could cancel these n minus 1 factorials together. So I'm left with an n times an n plus 1 times an n. And we could write our final answer as that if I have an n times an n, that's going to be an n squared times n plus 1. Okay? You could distribute that in. However, on your guys' test, when they ask you a question like that, they're going to say to leave it in factored form. So n squared times n plus 1 is what we would want to leave that as. And that is our factorial.